We are quickly nearing the end of Unit 3, which means we're going to have a test coming up soon. But before we get there, we're going to start working with our graphing calculators. Today we are exploring functions on a graphing calculator. So if you don't have a graphing calculator, you can always use our friend Desmos. You can go to Desmos, which you should be working on for your extra credit project. And I'm going to, you know how we do, we sign into our Google account. And there we go. So everything I can do on this, as well as the graphing calculators you were given during school. So we are going to use this function. We're going to graph this. And remember that f of x is really fancy, let me change that color, for y. And especially when we're graphing, because we need points x and y to graph, we have to remember that. So I'm going to get up our graphing calculator. So here's my graphing calculator. Now, to get used to your graphing calculator, we are going to learn how to enter this equation into our graphing calculator. If you find on the graphing calculator the y equals key, and we press it. If you have something in your y equals, you simply come to the clear button, press it, and it will clear out. I'm going to type now 1/2. Since 1/2 is a fraction, we are going to learn to put fractions in parentheses. And if I'm going too fast, just pause the video and see where each key is on your graphing calculator. We now have two options. We can either look at the graph or we can look at the table. So as you can see right now, I am saying that we would like to inspect the table first. So all a table is basically what we've been doing in math. It lists the x values. It does the calculations for us, although we won't see the calculations. All we see are the answers of what we get when we put these in. So this would be 2.5 if I put in, whoops, that's a positive. This would not be 2.5. This would be 1.5 if I put that into my graphing calculator, and I did. So let's come over here, and you press the second button and then the word graph. So we press this second function, and that enables us to look at these blue keys, and you can see blue table, and there we have it. As I press the up or down button, notice what's happening to my graph over here. It's giving me the answers to my table, and there indeed, if I put -1 in, I get 1.5. If you go over to the y value and you try to go up or down, it doesn't. So you must move up or down because x is the independent. The y depends on what value you put in for x. So we could use our table to do all these function evaluations, which we've been doing over the course of Chapter 3. So if we remember, our function is 1/2 x plus 2. Well, we could do this the long way. We could have put -6 in. When I put -6 into function f, this function tells me to take half of -6 and then add 2. Half of -6 is -3. -3 plus 2 is -1. So this is saying when I put -6 into my function, the answer is -1. Well, when I look at my calculator, look how easy this is. I'm going to go where x is -6, and it does the math for me. Simply amazing. All right, 0. When I put 0 in, let's be lazy. When I put 0 in, the answer is 2. Oh my goodness, look how easy this is. Oh, now we have to really understand functions. They didn't tell us what the x value was. They did tell us what the y value was. So when I go to look this up in the chart, I've got to come over here to my y's, and I'm looking for 11. Wow, I've got a ways to go. So I'm just going to keep going down this list and going down this list, getting closer until I see 11 pop up in the y place. Just a few more, and there it is. 18, when x is 18, y will be 11. Beautiful. So my answer is when x is 18, y is 11. Now we could have solved that out. I could have said 11 is the y value when I take half of some number and add 2 onto it. And I could have solved that. Half of what number gets me 9? 18. Good. So let me clean up this page. We are going to add another function onto our graph. Notice how it says function g? That means it's a different function than f. So I can go to my graphing calculator, going back to y equals, and instead of putting it in the first graph, I'm going to put it in the second graph. So what was it? 5 minus x. 5 minus x. And with my calculator, notice I show up in different colorful lines here. If I was going to graph this picture, it would look like this. There's my blue line, and now I get a totally another line, and it's a different color, so I can definitely see the difference between them. I have my table, and I have my picture. So we're going to review some of those words from the other day. Domain and range. Do you remember what domain and range mean? Well, that's right. Domain are the x values. So I'm going to drop a green line right here so we can look closely at this. And if you remember what domain meant, domain is the x values, the inputs. Is there ever a number that cannot get put into these equations? So in other words, here is, if I put the line right here, here's the x value, 1, 2, 3, 4, 5, negative 6. Does the x value of negative 6 cross the red line? Sure, way up here. Does the x value of the blue line, does x equal negative 6 cross the blue line? Yes. Is there any x value that it won't cross? No. So what we have here is the domain of g of x, which remember is our red line, is all reals. And that's how we write all reals. And the domain of f of x, which is the blue line, is also all reals. All right, so now what about the range? Remember, the range goes this way. Will every value cross the red and blue lines? Yes, because remember, this red line, even though we can't see it, goes on forever and ever this way. And this blue line goes on forever and ever this way. We are only looking at a little bit of it, a little picture of it. But they will cross Blue, red, cross green, blue, red, cross green, blue, red, cross green. Yes. So in here, it's the same thing. The range of function g is all reals, and the range of function f is all reals. How about the x-intercept and the y-intercept? All right, so we have to remember now. I'm going to do these in two different colors so they stand out. The x-intercept of function f, that was our first function right here. So all I have to do is trace along my blue line, and boom, right there is where the blue line crosses the x-axis, and that is the number 1, 2, 3, 4. So the x-intercept for function f is -4. Now notice I didn't write equals -4. I'm just trying to coordinate the blue and the blue. How about the x-intercept for function g? Its x-intercept is right there. That's where it crosses the x-axis. 1, 2, 3, 4, 5. Its x-intercept is 5. How about the y-intercept? The y-intercept for function f, which is the blue line, is right there. It crosses the y-axis at 2. And the x-intercept for function g, its y-intercept is all the way up there. That's 1, 2, 3, 4, 5. Now what about relative minimums and maximums? There are none here because there are no places that it curves. So the absolute maximum does not exist. It's infinity. It goes higher and higher and higher. And the absolute minimum is it goes lower and lower and lower. So it's negative infinity. And it's the same for the blue line also. The blue line goes off, gets smaller and smaller and smaller. And the red line, and the blue line's maximum gets higher and higher and higher. So we have no absolute maximum or absolute minimum in this particular example. Neither do we have relative maximums or minimums because we have no area that curves. All right, so let's look at a quadratic. We're going to type this in to our graphing calculator. I'm going to go back to y equals, and I'm going to clear out my other two, parentheses, x minus 1, parentheses, and then over here is a squared button, minus 4. I'm going to graph it. And there's my picture. So I can bring my picture out so I can draw all over it. Make it a little smaller. And I only want to look at the interval from -1 to 4. So I'm going to take a line here, and this is x is -1. So I only want to look in between my red line. Put that over to -1. Let's clone it. Move this over to 1, 2, 3, 4. So I don't care about any of this over here. And I don't care about any of this over here. I just care what's in between. Now, in between there, can you find all these words? Is there a relative minimum? Yes. Once again, let's go to my highlighter pen. It's right there. That's the smallest point of my graph. Can I find an x-intercept? Absolutely. It intercepts the x-axis here and here. So my x-intercepts, when I look at this, are -1 or 1, 2, 3. What was my relative minimum? 1, 2, 3, 4. Looked like -4 was the lowest my graph went. How about y-intercept? Does it cross the y-axis anywhere? Absolutely. Crosses the y right there. 1, 2, -3. Okay, so that's -3. Is there a relative maximum? No, there is no relative maximum. Is there an absolute maximum or an absolute minimum? Well, yes, there is. So absolute minimum would be the smallest part or the lowest dip of my curve, and the absolute maximum, minimum, remember, is here, is the same as this relative. So the absolute smallest part it gets to is -4. Now let's put that in the right spot. There we go. What's the highest point it reaches? Well, the highest point, according to this, is right here where we kind of overlapped it. And that would be the point 1, 2, 3, 4, 5, it looks to be. So the highest point it reaches is 5. Now the range and the domain, those are interesting. The range are the x values. And according to us, we only wanted to look at this picture from -1 to 4. We restricted the domain. We didn't care about all this over here, and we didn't care about all this over here. So when we restricted the domain, the range went -1 matched up with -4, so -4 is the lowest y value. And my maximum, what was the highest y value? 5. So if you understood absolute maximum and absolute minimum, it helps you find the range. And it also helps you find the domain, because the maximum point was 1, 2, 3, 4, the point 4, comma, 5. And the smallest point was the point -1, comma, -4. Does that look familiar now? That's right. Look at my domain, which are my x values. Hey, that's kind of cool. And look at my range, which is my y values. That's kind of cool also. So these words have double meanings. All right, so you can see I cleaned up the page. And I have one more question for you. How can this graph help solve the equation x minus 1 quantity squared minus 4 equals -3? So we're really, truly trying to see, do you really understand that this is fancy talk for y? Here we don't know what the x is. But we do know once we subtract 1 from it, square it, then minus 4 from it, once we do all this to the x, we get a y value back. In this case, it's the y value of -3. So I'm going to come over here, and I'm going to go into my lovely table. Do I see a y value of -3 here? No. I'm going to keep going. Y value of 21, 12, 5, 0. Hey, -3. Is that my only answer? No. Because if I look at -3 right here, look how many times it crosses -3. Let me bring that graph back out. Whoops. Y equals -3 is right here. And how many times does that green line cross that blue line? Twice. We can look right here and we can see that it looks to be when I put a 2 into the problem, I get a -3 back. And when I put a 0 into the problem, I get a -3 back. Is that what we found on our graphing calculator? Let's see. Let's go back to that table. Yep, when I put a 2 in, I get a -3. And when I put a 0 in, I get a -3. Okay, we'll see you tomorrow.